Hi guys, I welcome you all to another session on time value of money. In the last video, we understood what is the meaning of present value, what is the meaning of future value, and how exactly is present value supposed to be calculated. Along with that, we understood two terms. The first one was compounding factor, the second one was discounting factor. Today, we are going to dive deeper into what is your discounting factor. So be with me as I discuss this point with you. Discounting factor. Your discounting factor is the number by which you multiply the future value to get the present value. Discounting factor is the number by which you multiply the future value in order to get the present value. Now, another word for discounting factor is present value factor. Another word for discounting factor is present value factor. And yesterday we understood how exactly is the discounting factor calculated. Discounting factor is 1 upon 1 plus r raised to n, where r is the annual rate of interest and n is the period in number of years. Right now we are only talking about annual calculations. Half yearly calculations, quarterly calculations, monthly calculations, we'll come to that in some time. Now, discounting factor is 1 upon 1 plus r raised to n. So, if I were to give you a situation where I ask you to calculate the present value of a sum of rupees 10,000 to be received at the end of different periods of time, what I would do is I would write down the year, I would mention the amount, and then I would have a separate column for the discounting factor. So, money received at the end of year 1, at the end of year 2, 3, 4, 5, 6, so on and so forth. And maybe the last number I want to check this for is 50. I want to check what is the present value of a sum of 10,000 to be received at the end of the 50th year. I mention my future value in this column. Pay attention. Now, how do we get the discounting factor or the present value factor? It is 1 upon 1 plus r. Rate here is 10% raised to 1. Raised to 1, 2, 3, 4, 5, 6, so on and so forth. And this is my last number. Okay. So from year 1, I have gone up to year 6, and I also want to calculate what is the value at the end of the 50th year. Now, discounted cash flow or the present value of future cash flow. Discounted cash flow or present value of future cash flow is a simple calculation where I multiply this amount with the discounting factor. So 10,000 into 1 upon 1 plus r raised to n gives me the present value. So I populate this column. Now, what does this column tell me? What is this 9091? 9091 means if I were to receive 10,000 after 1 year from now, the present value of that 10,000 is 9091. And if I were to receive 10,000 2 years from today, its present value would be 8264. If I were to receive 10,000 after 2 years from now, the present value would be 8264. So on and so forth. If I put it across as for the 50th year, if I were to receive an amount of 10,000 after 50 years from now, the present value would be 85. Now, if you observe one thing, if you observe how the values are moving, you will very clearly see a trend. And what trend do you see? As you move ahead in time, as you move further away from the present date, your present value, your discounted cash flow value keeps on declining. The further you move away from the present date, the discounting factor keeps on reducing. So let's make that observation. So what happens when we move further away from the present date. Now, the discounting factor keeps on reducing and the present value also falls as we move away from the current date. The discounting factor keeps on reducing and the present value also falls as we move away from the current date, which means the farther you go, the lower is your present value and the lower is your discounting factor. So this is our first observation regarding discounting factor. And what is that? The further we move away from today's date, the lower is the present value. Let's now try to find out, this is our first conclusion. Let's try to find out if there is a relationship between the rate of interest and the discounting factor. Okay, so is there a relationship between the rate of interest and the discounting factor? Now, for this, I would want you to look at this calculation with a couple of different rates of interest. So we'll copy down this part as in year 1 to maybe just say, let's take year 1 to year 5. Let's not, add too many years in this. Discounting factor at the rate of 10%. You already have that calculation ready-made here. Discounting factor at the rate of 10%. Then discounting factor at the rate of 15%. How much is that? 1 upon 1 plus 15% raised to 1. Raised to 1, 2, 3, 4, and 5. Raised to 2, raised to 3, raised to 4, and raised to 5. So this is my discounting factor, assuming that the rate of interest is 15%. And let me see what is my discounting factor if the rate of interest is 5%. So 1 upon 1 plus 5% raised to 1, so on and so forth. Raised to 2, raised to 3, raised to 4, and raised to 5. Now, I have my discounting factor values. What I want to do is let me see what is my discounted cash flow. Discounted cash flow in this case would be the amount of cash flow into my discounting factor. The amount of cash flow into my discounting factor. Let's see the sum total for this one. The sum total for this one is 37,908. Observe this column. I'm putting it in one color. Now observe the discounting factor for 15%. Observe this particular column. If I have to calculate my discounted cash flow or the present value of my cash flow, I multiply the amount with the discounting factor for 15%. I want you to focus on the column for discounting factor. I'm coloring this in blue. Have a look at this one. And the last one that I want you to have a look at is the discounting factor column for 5%. 10,000 into this. Now, as I populate all the columns, observe what is happening. There are 3 different columns for the discounting rate. I want you to observe all the 3 columns. Now, as the interest rate rises, see, as it went from 10% to 15%, you see the discounting factor is getting lesser and lesser. For the first year, it was 0.9091. Here it is 0.8696. For the first year, it is 0.8264. When the rate of interest is 15%, it is 0.7561. For year 3, it is 0.7513 for 10%, but for 15%, it is 0.6575. So as my interest rate has gone up, my discounting factor has gone down. And look at this column, discounting factor for rate 5% when the rate of interest is 5%. So for year one, when the rate of interest was 10%, this was 0.9091. When the rate of interest was 5%, the discounting factor was 0.9524. For year three, if you compare, for 10% it was 0.7513 and for 5% it was 0.8638. What is your one takeaway from this particular calculation? Your one takeaway is, as my interest rate rises, my discounting factor falls. So as my interest rate rises, my discounting factor falls. That means there is an inverse relationship between the rate of interest and the discounting factor. There is an inverse relationship between the rate of interest and the discounting factor. So our first takeaway was, what happens when we move further away from the present date? The farther you go, the lower is your discounting factor. And what is your key takeaway from the second situation? Your key takeaway is that the farther you, in the second situation, your key takeaway is, if the rate of interest increases, the discounting factor falls. That means there is an inverse relationship between the two. Before I teach you how to use the calculator for these calculations, I want to introduce you to a table which is known as the discounting factor table. Now, the discounting factor table is a ready-made table that is given to you in a lot of exams. And this discounting factor table contains all of these values. So, how to use the discounting factor table? What I have done is, I have taken a screenshot from one of the publications. Let me show it to you how exactly, or what does the discounting factor table look like. If you observe here, this is your present value table or the discounting factor table. Say suppose the rate of interest is 10%. You come to the 10% column. You want to calculate, you want to know the discounting factor for year one. Then the discounting factor for year one is, go to row 1, 10%, row 1. Where do these two meet? They meet at 0.909. Now, what if I want the discounting factor for year 3? I come to the 10% column, I trace the year, I trace the row for third year, I go in this direction, I land up at 0.751. So you pick up the rate, you go to the rate column, go to the year that you are looking out for, trace the position where the column and the row meet. That is your discounting factor. So if I need discounting factor for a rate of 7% for year 6, I will land here 0.666. Now let's see what happens. Is there a difference in the answer that you get when you use the discounting factor table and when you use the formula? Let's see that. So difference in values on account of approximation. Okay, so let's write down the year. Let's write down the amount. Discounting factor at the rate of 10% using formula and DCF, that is discounted cash flow, or I can also call it present value if you want it that way. And discounting factor at the rate of 10% using table. We're going to look at the table and then we'll see what the present value comes down to. Okay, now be with me, okay, as I perform these calculations. I would need your attention. Now, if I were to begin, let's take, a number like 1 lakh rupees. Okay, instead of 10,000, let's use a slightly bigger number. Year 1, 2, 3, 4, and 5. Amount. Say, I'm talking about a sum of 1 lakh. which is received at the end of each of the 5 years, 1 lakh each year. Now, if I use the formula for discounting factor is 1 upon 1 plus r raised to n. So 1 upon 1 plus r, that is 1 plus 10% raised to 1. 1, 2, 3, 4, and 5. Now, what I'm doing is I'm simply approximating this, and I'm showing the decimal representation up to 4 digits after the decimal point. Now I multiply 1 lakh with this discounting factor, I will get my present value. Let's take the total of this column and keep it ready. If I use the discounting factor table, I will use 0.909, 0.826, 0.751, 0.683, and 0.621. So 0.909, 0.826, 0.751, 0.683, and 0.621. Now, if I want to arrive at my present value, what should I do? Pay attention. What I'm going to do is, I'm again going to multiply this 1 lakh with 0.909. Now, check the difference in the values. For each year, I want you to check the difference. If you are using the formula, your present value is 90909. If you are using the discounting factor table, your answer is 90900. How much is the difference? The difference is 9. Then in the year 2 values, the difference is 45. In year 3 values, the difference is 31. Then it is 1. Then it is minus 8. How much is the total difference? The difference between these two values is a net amount of 79. Now, naturally, as if the number of values are more, this difference might increase. But overall, I can only see a difference of 79 rupees in the two values. Now, focus on these two columns. I'm putting this in green and this one is in blue. What I want you to do is I want you to observe how the two values are different from each other. Now, if you observe this column, 0.909, I'm increasing my decimals. It is 0.9090990. So it's an approximation. I have stopped it at 4 digits after the decimal point. Here, I'm straight away using the number 0.909. Naturally, the two values would be different by a small margin if you are using the formula versus if you are using the discounting factor table. There is always going to be a difference. There is always going to be a difference between the present value calculated using the formula and present value calculated using the discounting factor table. But the difference is so small that it never impacts your final answer. Any difference on account of approximation, any difference on account of such approximation does not impact the calculations and your final answer. You will get full marks. So this is one question, that a lot of students come to me with, that the answer given at the back is so and so, my answer is so and so, will I lose marks on this topic? It's very clear that any difference that comes in your answer, if it is a difference on account of approximation, it will not have any impact. You will not lose any marks, whatever approach you take. So make sure that you understand why it is happening this way. We understood 3 things about the discounting factor. The first thing that we understood was the farther you go, the farther you go from today's date, the value declines. If your rate of interest is more, your discounting factor is less. And the answer that you get using the formula for present value and the answer you get using the discounting factor table, there is going to be a difference between the two, but the difference is small. It does not have an impact on the final answer. and the final conclusion you arrive at. It's not as if just because you have used the table instead of using the formula, a positive NPV situation will not become a negative NPV situation. What is NPV? We'll understand in some time. Right now, I just want you to absorb the entire concept around how discounting factor is calculated, how is the present value table used, and what is the relationship between different variables. This base knowledge will be used in a lot of other areas when we study those further.